Hello guys, so today we're going to be solving problems on dependent sources. So let's just recap what dependent sources are. So we have um, independent sources such as independent voltage sources and independent current sources, or we can have dependent voltage sources. So again, the dependent voltage sources depend on a current in the circuit or the value of a specific voltage in the circuit. And dependent current sources can also depend on either a current or a voltage value. So let's look at the specific problem. The specific problem asks us to find Ix, right? And so basically here we have a dependent current source, and it depends not on a voltage in the circuit, somewhere in the circuit, but it depends on a current. So it's a current dependent current source. So the current it depends on is Ix, which is the current through this specific resistor. So how can we solve this problem? Well, it's very simple. All we have to do is use KCL, or Kirchhoff's current law, which basically says that the currents entering or leaving a specific node has to equal 0, right? So it's very easy. Let's just solve it at this node. We already called this node 1. So at node 1, we just apply KCL. So it's very easy. So we have a current entering the node. So anything entering the node, we will give it a positive value. So we have positive 44 milliamps. And then this current Ix is leaving the node, as you can see. So this will have a negative value, so minus Ix. And this current also is leaving, so it's going to have a negative value, so minus 10 Ix. And all of this should give us a 0. So as you can see, this is a very simple problem. So when you solve this, you should get 4 milliamps. And that's it. It's very straightforward. So guys, let's look at another problem. So the problem asks us to find the voltage V0. So as you can see, this circuit includes a dependent voltage source, which depends on a voltage, right? It depends on the value of a voltage at a different part of the circuit, specifically the voltage drop across this resistor 1K. So how can we solve this problem? Well, it's fairly straightforward. All you have to do is apply KVL, right, which is Kirchhoff's voltage law, which states that the voltage drop across a loop in a circuit, so through a loop in a circuit, should give you 0. So let's just apply that. So if we move in this direction, we first encounter the negative, right, of this independent voltage source, because we're moving in this direction clockwise. So let's just write that down. So we have negative 12 volts plus, because the current is moving in this direction, right? So the voltage drop across this will be positive, because we're assuming that the current is positive and in this direction. So if we assume that, we just have to write the voltage drop across this. So what is the voltage drop across a resistor? Let's just remind you guys. So the voltage drop across a resistor is the current times that resistor. So the current here, we just have one current in the circuit, we'll just call it I, and times that resistor value, which is 3K, 3000. Okay, and as we move forward, we have the positive, we have the positive polarity of this voltage source. So we add this value here, because it's positive here and we're moving in this direction. So we add to V naught. And then we just have V naught here, again, because we're moving in this direction, right? So what is the polarity, the first polarity you find? It's positive, right? So we add V naught. And all of this should give you 0. Now, what else do we know about V naught? So V naught is the drop, the voltage drop across this resistor, right? And what do we know about the voltage drop across a resistor? So we know what the voltage drop across this resistor is. So V naught is the same as the voltage drop across resistor 1, which is equal to what? The current times the resistance. So we already said that the current in the circuit is I, and we'll multiply that by 1, which is the value of the resistor. So we can now substitute this, or rather we can substitute for I, because we have two variables in this equation, right? We have V naught and I, and we want to find V naught. So we'll substitute for the I in terms of V naught. So if we solve I for V naught, we just get this. I is equal to V naught. So we just have to substitute this here, and it's a very simple equation and you can solve it really quickly. And what you get for the V naught is 2 volts. So fairly straightforward, simple problem.